I built this security alarm using Raspberry Pi Pico, passive infrared sensor, ambient light sensor, audio amplifier, and 2 speakers. It is powered by normal USB power supply. Always wanted to do something like this, but wasn't very motivated. But one late night I received this motivational video. So how does it work? Now I'm taking Intruders head on and walking to my porch, and it starts barking. Now I'm taking my gardening hat on, I'm taking my watering can and water my plants, and nothing happens, it doesn't bark. Let's rewind a few months back to the time when I started the project. First of all, when this happened, I identified a problem. The push notification from the camera arrived too late when the intruders have already left with the loot. And second, they didn't notice the camera or they didn't care about it. This looked as an opportunity to start a project with a controller and some sensors. I self-imposed a constraint of $50 for entire project and ordered some stuff online. The parcel has arrived. This was the first time I was doing anything with Raspberry, so I started from basics. Blinking LED, buzzing the buzzer, prototyping. Pretty soon I was ready to start building. The planned algorithm was simple. It should bark when the motion is detected, but only when it's dark. Primary components of the system are Raspberry Pi Pico, ambient light sensor, passive infrared sensor, audio amplifier, extension board for convenience, and assorted wires. The GitHub repository of this project has all the code, schematics, bill of materials. I will leave a link in description. To program your controller, you may use Sony IDE, which will help with everything, but I used mpremote from Micropython directly. First of all, you need to install mpremote if you're using mpremote, and then you need to flash your controller with Micropython. So you go to Micropython website, you just find it in your search engine. You go to downloads page and you find your controller, for example, Raspberry Pi, and choose a version of your controller. This could be Raspberry Pi 1, and then you need to plug it in and upload one of these files into your controller. So this is different for all different boards, but for Raspberry Pi Pico, usually you just hold this bootsel button and you plug it in with USB cable, and it loads in bootloader mode, where you can simply upload this UF2 file to flash it. So once you've done that, you can start programming it. Please let me know in comments if you want a comprehensive tutorial on coding Raspberry Pi Pico with mpremote and Micropython. The first challenge was to make Pico play sound. I found this library from Daniel Perron, which uses pulse width modulation to play sound. It's very easy to use. We need to install the libraries with mpremote MIP install. So we just need few files from Pico Audio PWM and 2 files from also Micropython. Once you have this, the piece of code to play sounds is trivial. Connecting the amplifier to make it work with this Pico Audio PWM requires this wiring. So we plug amplifier power to 3 volts on Pico, and we use GPIO 2 and GPIO 3 to connect left and right inputs of amplifier. We would need some resistors here, but they are, strictly speaking, optional if the amplifier itself already has resistors, so they are essentially here. And we'll add some capacitors later, but we'll get back onto that soon. So here's amplifier, we wire speakers, We ground it, and it should be able to play sounds. Dealing with passive infrared sensor was a relatively easy task. I just wired that to one of the pins and didn't need any special extra software, so I just binding it to this pin with machine pin, just normal Micropython thing, and then I add a handle and I start intercepting it in a main loop. And if we have here sensor state true, which we trigger when it detects motion, we call this handler motion detected, and we get later on that onto light, but basically we just play sound. That's how it works. Just a couple little nuances about infrared sensor. These labels I added myself, but normally here it doesn't have any labels, so you don't know what is what here, and the secret is quite often you just take the lens off and you can see it's labeled VCC out and ground. Another thing, documentation states it wants power of 5 volts, and quite often I've seen that people are using some external power. I tried to use VCs, which is pin 39 on Raspberry Pi, and it actually has 5 volts from USB, and it's been working pretty fine. And just one last thing, the sensor has these 2 potentiometers, and you can tune them to make it work fine for you. One sets sensitivity and one sets interval, how often the event is triggered. So you would set them to some positions and just experiment and see what works for you. Now that amplifier and passive infrared sensor are working, it's time to switch to light sensor. Both expansion board and the light sensor are made by the same company, so they have special connector which makes it a bit easier, but it requires special software to make it work. The software, or a driver if you like, is available from vendors, GitHub, and it can be installed with mpremote. Alright, the system is mostly ready, let's test it. So we start the application, it plays the test sound, all seems to be working. And now we see it detects motion, but it doesn't play sound because the light sensor doesn't deliver signal. So now let's close the light sensor with this breadboard and look at that, plays the sound. So now we decided to test it in more realistic situation. It all worked, but there was one problem, a little problem. Can you hear this howling sound? I discussed that with my cousin and we concluded that this may be caused by pulse modulated audio, maybe something in inner circuits in Raspberry Pi, and the solution should be a low pass filter. I quickly prototyped a low pass filter from scavenged SMD capacitor, and it sort of worked, but I didn't even know what's the capacitance of this capacitor. So we discussed a little bit more and found a formula to calculate the capacitance of low pass filter. We targeted a frequency of 36 kilohertz, which would fit most of the audible sound. So we headed to the electronic shop to buy some stuff. We bought capacitors, some heat shrink tubes, and enclosure for the device. Yeah, and the project was pretty much done. I've built a filter, low pass filter. It was working fine and looking good. Assembled everything in the case, and we are done. It's time to do the final assembly. Now I will try to reproduce assembly process. I recorded this recently, whereas the actual project happened more than a year ago. Final step is putting everything together. I prepared enclosure, I drilled holes for speakers, I cut out the hole for the USB. Without 3D printer you have to be creative, and I used some timber scraps. And surprisingly, the hardest part to procure were small screws which would go through these small holes in boards, and I just succeeded just because of my hoarding habits. I tend to keep all these small screws I found in many different broken devices and toys. I pre-drilled all the holes. I made grooves for the pins because, for example, with amplifier we have a bunch of pins sticking from down here. We don't want to bend them or cut them. Alright, time to start wiring. I made an improvised connector to connect the peer sensor, and markings obviously show that we used conventional colors, so we have red for power and black for ground. And we are all done. I just rechecked the code and I think schematics is wrong, and this wire should actually go to this, which is GPIO 27. Finally, after assembling and fixing wiring problem, it's time to test it. Important to note, this infrared sensor has two potentiometers here, and you need to tune them and find what works for you. Alright, let's power it. So it's playing test sound to check the system works, and I'm moving next to the sensor and nothing happens. But when I cover it with a book, so it's working as intended. I just wanted to say thank you to my cousin. He was really helpful. We discussed this sort of stuff with him quite often, and all this video is possible because I was sending photographs and short videos in a messenger to him. Thank you for watching. Like and subscribe.